Good day, students. Welcome to mathgotserved.com. And this clip we're going to be going over question number 5 of the 2019 AP Calculus AB free response questions. This particular presentation will be focusing on area and volume. All right, question 5 reads, let R be the region enclosed by the graphs of g of x equals -2 plus 3 cosine pi over 2x and h of x equals 6 minus 2 times the quantity x minus 1 square. The y-axis and the vertical line x equals 2 as shown in the figure above. Okay, so we have a function, two functions, the y-axis and x equals 2. The first question is find the area of region R. Alright, so region R is bounded by two curves. Let's start off by writing down what the formula for finding the area between two curves is. Okay, so the formula is as follows. Formula for area between two curves. Alright, so the area is given by the integral from x left to x right. Now, something to keep in mind is the configuration of your functions. Okay, if they're oriented vertically, like this, up, down, in the direction of the x-axis, okay, that means that you're going to be integrating with respect to x. But had it been that they're configured horizontally, let's say you have something like this, a function like this, and then another function like that. In this particular case, you're going to be integrating with respect to the y-axis. Okay, so pay attention to the configuration of your graphs. If you're confused as to how to do it, just ask yourself, how do I slice the region in such a way that I do not hit the same function twice? If you hit the same function twice, you might want to switch directions, okay? So let's say I wanted to do it in the y direction, and I check out this slice right here. I'm going from this, the function, to itself. How can I calculate the area there? It's going to be problematic. I'll have to split it. But in the other orientation, in the entire domain that you're integrating, you're going from one function to the other. You never go from one function to itself. Okay, so that's an easy way to determine what direction that you're going to go. All right, so this is top-down configuration. We're going to be using integration with respect to x. Okay, so that's why I have x left, x right of the function on the top minus the function on the bottom. And this entire thing, these are functions of x, okay, dx. Had it been that it were configured horizontally, okay, so this is a top-down configuration. If it were configured horizontally, your area will be the integral from y bottom to y top. Okay, it's all going to be y's, and then this would be the function on the right. This would be a function of y, okay, minus the function on the left. And this entire, oh snap, let's fix that. Function on the left has a function of y, and in this scenario is going to be integration with respect to y. So you see the difference. In this particular problem, we're looking at a top-down configuration, so we are going to be using this formula right here. Okay, all right, so all you just need to do is find the left right bounds of x, the top function, and the bottom function. All right, so let's do it. So what is x to the left? X left, the x-axis, let's look at the region right here. So the left bound of the region is your x left, all right? And then the right bound is your x right. So we have, you were going from 0 all the way to 2. Those are our boundaries for x. So x left is 0, and x right, or b, is 2. Okay, so what's f top? The function on the top. Now we have two functions here. We have a trig function and a quadratic. So if you look at the functions, you can easily tell which is which. All right, so if you look at the top function, you can clearly see is a quadratic function that has been flipped downwards, dilated horizontally, and shifted 1, 2, 3, 4, 5, 6, 6 units up. Bam. So the top function is h of x. Okay, so make sure you get your top and bottom functions correct, or else your entire answer will be wrong. Okay, so f top is h of x, which is 6 minus 2 times x minus 1 quantity square. Let's just write down how we knew that that was the right function. We have a parabola that is flipped downwards. All right, so if you look at this negative in front here, that tells you that the parabola is flipped vertically, okay? Flipped downwards, dilated horizontally by a factor of 2. So you see that 2 right there, that's a horizontal dilation. And then it's shifted 1 unit to the right. See that minus 1 there? And 6 units up. This positive 6 right here. Okay, so brief little review on pre-calculus for you. Transformation of functions. Okay, so we know what the top function is. Now we need the bottom function. The bottom function is what? The bottom function is the transformed trigonometric function, which is negative 2 plus 3 cosine pi over 2x. And we know, we can easily see why that's the case. All right, so we're looking at a trig function. We know it's periodic in behavior. This clearly is a cosine function that has been shifted downwards and has a period. So half of the period is 2, so the period is going to be 4. Okay, and what else? Let's see, the amplitude is 3. So from the central, from top to bottom is going to be double that. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so we can clearly see the agreement there. So let's go ahead and justify why we selected this as the bottom function real quick. This is just FYI. Nice little review on pre-calc. So it's a cosine curve. We know what the cosine curves look like, right? It's like a nice little cup that goes one period of your cosine function. And when we split it in half and shift it, you have what we have over there. So the cosine curve, it has an amplitude of 3. Okay, because of that 3 right there. The period is 4. When you do 2 pi over b, you do 2 pi over pi over 2, drop change flip, you end up with 4. The period is 4. It's shifted 2 units down. How do we know that? Well, you have this minus 2 here. That's a vertical shift, shifted 2 units down. Okay, so that's how we know what's the top and bottom function. Ladies and gentlemen, we are ready to evaluate the integral. So the area, using the formula, is the integral from x left to x right. So from 0 to 2 of the top function is h of x minus the bottom function, which is g of x. Let me do a real quick correction. I didn't write it there, so let me put it in. So this guy right here is g of x. This is a no calculator problem, so we have to write everything down in order to get full credit. Okay, so this is dx. All right, so there's your area right there. Now let's plug in the functions. We're looking at the integral from 0 to 2. Let's insert h of x. H of x is your quadratic, 6 minus 2 times the quantity x minus 1 square. So that's h of x. That's minus the trigonometric function, negative 2 plus 3 cosine pi over 2x. Okay? All right, we're going to be using FTC1 here, so it's pretty long. Prepare yourself. Okay, let's do this. So if you look at our integrands, you notice that we'll have to use u substitution twice because we have a composite here in a composite function here. Okay, so that's one way to do it. So what I'm going to do is I want to show you use substitution out, and I want to show you another way to integrate composite functions that are quadratic. Okay, if you can expand a quadratic function, you don't have to necessarily use the use substitution. Just expand it and then go from there. Okay, all right, so I'm going to use substitution for the trig part, and I'm going to use expansion and simplification for the quadratic parts. You can use sub for both. Okay, all right, so let's go ahead and do what I'm talking about here. So what I'm going to do is I'm going to expand the polynomial on the left and then simplify it completely. All right, I'm trying to do just one use substitution here. So if I expand this, I have 6 minus 2. When you expand x minus 1 square is a squared minus 2ab plus b squared, so x squared minus a squared minus 2ab. That's too thick. Minus 2ab plus b squared. Okay, and then distribute this minus to everything here. It becomes plus 2 minus 3. So please pay close attention to the minuses because they're very important and can easily ruin your answers. Okay, there we have it. All right, so let me simplify this further. I'm going to have the integral from 0 to 2. Okay, and then just distribute this 2. So negative 2 times x squared will give us negative 2x squared. Negative 2 times negative 2x will give us positive 4x. Okay, and then negative 2 times 1 is negative 2. So we have negative 2 plus 2 plus 6. What's that going to be? Negative 2 plus 2 plus 6 is just going to be positive 6. Bam. Okay, so minus 2 times 2 combined with that cancel out, just bring the 6 over. All right, so what I did is I was trying to avoid dealing with the doing use substitution twice. All right, but we have to use sub for this guy right here. Okay, so now that I've done use sub for the left side, I can just use the power rule, and then this one right here, I'm going to use substitution. So let's split it up. Okay, so polynomial to the left. So we have negative 2x squared plus 4x plus 6 dx. And then our trig function to the right. Let me factor out the 3. All right, I'm keeping it separate because I'm using 2 different integration techniques. I don't want to get myself confused with the work. Okay, so we're ready to go. Let's do the first one. First, the polynomial is easy to do. We all know our power rule for integration. When we apply that to the polynomial on the left, we are going to have negative 2 power plus 1 over power plus 1 plus 4x to the power plus 1 over power plus 1 plus 6x. And this is evaluated from 0 to 2. All right, so no use substitution here. Piece of cake. Oh, this one is a different story. Let's integrate. Let's find the antiderivative of this. So I'm going to be using the use substitution method here. Now, how do you know to use sub? When you have a composite function and the derivative of the inner is an integer multiple of the outer function of the second function, then you know to use sub. Okay, so we are integrating from 0 to 2 cosine pi over 2 x. All right, so what is u and what is the u? So let's see. The inner function is going to be u. So this guy right here, this is u. Okay, so let u be pi over 2x. Then the u is going to be pi over 2 dx. Okay, so we have we can take this out and replace with u, but we need dx alone by itself, so we need to get rid of this pi over 2. So what we do is we multiply both sides by 2 over pi. or just divide by pi over 2. We could do that. Okay, so let's divide by pi over 2 or just multiply by 2 over pi. Let's multiply by 2 over pi. It looks nicer that way. So multiply by 2 over pi. Multiply this by 2 over pi. Okay, so we're going to have 2 over pi du equals dx. All right, so if I want to take away dx, I'm going to replace it with 2 over pi du. You need to know exactly what you're substituting first before you carry out your u sub. Okay, now I'm going to integrate from x equals 0. I'm putting x's here for a reason you'll see in a second, to x equals 2 of cosine u times 2 over pi du. All right, you can factor out any constant, so 2 over pi times the integral from 0, from x equals 0 to x equals 2 of cosine u du. Okay, now when I integrate cosine u, what's the integral of cosine u? The integral of cosine u is just sine u. Remember, the derivative of sine is cosine. Okay, so we're going to have 2 over pi of cosine, nope, our integrate is no longer cosine, it's sine, sine u, evaluated from 0 to 2. Okay, now this is a question. This is a big mistake many students make when they carry out u substitution on definite integrals. So this is a question I have for you. Can I plug in 0 and 2 into this integral, this antiderivative? The answer is absolutely not. Notice that x goes from 0 to 2, but this is u. The variables are not in agreement, so you can sub. Okay, so what must we do? We have two options. Option 1, you change the limits using your u value, which is pi over 2x. Okay, or option 2, you resub u, the value of u, back into your antiderivative. Whichever way you do it, you're going to get exactly the same answer. Alrighty, I'm going to resub. Okay, so I'm just going to resub. Let everything be in terms of x. So before you start plugging in, either they are all x's or they are all u's. You can have u and x and get the answer correct. Okay, so let's bring down pi over 2x in there. That's what u is. Now, since it's in terms of x, I can plug in. Okay, all right, so I'm going to put it back here. Since we are at the same level now, antiderivatives being evaluated at upper and lower limits. So what do we have here? We have -3. Oh, we also have 2 over pi sine pi over 2x. Okay, and that's evaluated from 0 to 2. So this guy right here, plug in the upper and lower, that's FTC1. So if you evaluate the antiderivative at the upper limit, you're going to have -2 cubed over 3 plus 4 times 2 square over 2 plus 6 times 2. Guess what happens when I plug in zeros? They all go to 0. So I don't even have to waste my time with the lower limit because they all have x's there. And when you plug in 0, they all end up being 0. Okay, so that's very convenient. Over here we have minus. So let's see. How about we factor out the coefficients to simplify our computation? Anytime you can factor out a coefficient, please do so. Makes your life real easy. So let's see. 2 over pi times 3 is going to be 6 over pi. Okay, so 6 over pi. We're going to evaluate sine. You know what, let me just show you exactly what I'm doing. I don't want anybody getting confused here. Okay, so what I just did is I just factored out the coefficients 2 over pi. Okay, all right, simplify this. PEM does this real quick. Order of operations, -16 over 3 plus 222 is 8. 6 times 2 is 12 minus 6 over pi. And then we have evaluate it at the upper, that'll give you sine of pi over 2 times 2 is pi, minus the lower sine of pi over 2 times 0 is sine of 0. Okay, all right, if we work this out, we're going to have negative 16 over 3 plus 20 minus 6 over pi. Okay, what is sine of pi and sine of 0? You could use the graph or the unit circle. Okay, let me show you both ways. So if I wanted to use the sine graph, it's an axis angle, so that's why I'm using the sine graph. So your sine graph goes like, that's just a dreadful diagram. I'll draw it again. So bam, 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 bam. So that's one period of your sine function. All right, so when you're looking for a sine of 0, pi, or 2 pi, the graph, the sine of multiples of pi over 2, 0 pi over 2 pi, 3 pi over 2 pi, 2 pi is it is easy to use a graph, or else use a unit circle. Okay, so this is pi right here, and that's 0. So this is y equals sine x. So you can clearly see that sine of pi is 0, and sine of 0 is 0. Bam. Okay, if you wanted to use the unit circle, let's look at that one too. You just remember y, the y coordinate on unit circle is sine and the x coordinate is cosine. So let's say you wanted to use your unit circle. Bam. Okay, let's do it. Oh man, this is a circle, it's weird. Okay, so what do we have? Let's see what we have here. This is 0 degrees, and this is pi. Pi is equivalent to 180 degrees, okay? All right, so this coordinate right here, unit circle 1, 0, and then this coordinate right here on the unit circle is negative 1, 0. So remember y sin, so the y coordinates for both of them are both zeros. You can see that sine pi and sine of 0 are both 0. Okay, so this guy right here is sine of 0, and then this guy right here is sine of pi. Okay, so let's simplify this. If we simplify this, we're going to have negative 16 plus 60 over 3 minus 0, and your final answer will be 44 over 3. Okay, so that's how you use definite integrals to find the area between two curves. Alrighty, so how was this graded in the AP exam for 2019? This was a 4-pointer. That's a lot of points. You get 1 point for setting up your integral correctly here. Bam, 1 point. You get another point for integrating the trig component correctly. Let's see. If you integrate this correctly right here, you get 1 point. And then if you integrate the polynomial piece correctly, you get another point. And then if you carry out your trig evaluation and arithmetic computations correctly and end up with 44 over 3, you earn another point. Ladies and gentlemen, you get a total of 4 points for this question. Okay, there you have it. Alrighty, let's take a look at question number 4b. In question 4b, we're going to be calculating how to find the volume of regions solids with known cross sections. Alright, so let's read the question. Question 4b reads, region R is the base of a solid. For the solid, at each x, the cross section perpendicular to the x-axis has area A of x equals 1 over x plus 3. Question, find the volume of the solid. Okay, all right, so this is a very convenient problem. A lot of times on the AP exam, when you're dealing with volumes of solids with known cross sections, you have to do some computation to determine the area of the expression for the area of the cross section. But in this case, you are already provided with it, so that is very, very convenient. Okay, so let me just give you a visual. This is not necessary by any means. Let me just give you a visual as to what we're dealing with here. So if you want to give yourself a visual, what you want to do is make the region a base. Okay, so this is a base. I'm just going to rotate the y-axis downwards a little bit. So let's say this is the function on the top, the trig function. So the trig function is something like that. And then the function, no, that's the quadratic, I'm sorry. And then the trig function is on the bottom. Okay. And then you have something like this. Bring it down a little bit more. Right there. All right. So you just rotate your region down, make it flat, okay? Now this is the base of the solid. But this expression basically represents the area of the cross section, okay? Perpendicular to the x-axis. So this is your x-axis right here. So on top of this, I'm just going to give you one slice, okay? So this is not correct. It's just a rough sketch, okay? So let's say it looks something like, let me change the color. This solid on top of here, it doesn't matter how you draw it. Let's say it looks something like this, okay? All I need to know is the boundaries A and B and what's the area of this cross section is. There's going to be an infinite number of them, okay? Infinite number of these guys right here stacked on this base. So when we accumulate all those areas, you get the volume, okay? All right. So let's see. We're going to start off by writing down the formula that will guide our problem solving process. All right. So formula for volumes of volumes with cross section perpendicular to the x-axis. So the volume V is the integral from A to B of your area. This is a Sachs formula right here. Bam, there you have it. If it's were perpendicular to the y-axis, guess what? This is just going to be A of y dy. Okay, and then you're going to go from y bottom to y top. So think about A is just similar to the previous problem we did. It's x left to x right. If it were perpendicular to the y-axis, it would be from y bottom to y top of A of y dy. Okay. Okay. Now what you want to notice is that A of x is the area of the cross section. Is the cross sectional area. It could be a semicircle, it could be a square, it could be a rectangle. But in this case, they gave it to us. It's a rational function. So we just take what we're given and run with it. All right, so we are going to list what we know and then find what we need. So in this problem, the left boundary, or x to the left, is 0. The right boundary, b or y to the right, is 2. The area of the cross section is 1 over, is a function. It's a variable area. Okay, so there you go. Ladies and gentlemen, we are looking for the volume. So your volume is unknown. Okay, so let's plug this into the formula right here. So the volume is going to be the integral from A to B of 1 over x plus 3 dx. Ladies and gentlemen, this is a composite function. How do you integrate composite functions? You can use u sub. If you have a known derivative composed with a linear function, you can use reversal composed with mx plus b. So one of those two ways. I'm going to use u sub. If you know how to do reversal composed with mx plus b, you can just see that the outer is 1 over u. So you just have ln of x plus 3 divided by 1 as the antiderivative. Okay, so let's use u sub, something that everybody's familiar with. The inner function is u. Okay, how do we know that that's u? Well, if you differentiate this, you're going to end up with a multiple of the other function, which is dx. Check this out. When you differentiate this function, the left side is 1 du, and then the right side is going to be 1 dx. Beautiful. So this is the u, and this guy right here is the x. I'm sorry. This is u, and this is the u. This is similar to the previous to question 5a, where we use u sub. Make sure you know exactly what's going where before you substitute so you don't mess up the problem. Okay, now we also want to change the limits. You can either change the limits so everything is in terms of u, or you can resub after integrating so everything is in terms of x. I want to keep it in the u world, so we need the u upper. U upper is going to be u upper. So the upper limit for x is 2, so the u upper is going to be 2 plus 3. So everything advances by 3. So u upper is going to be 5. And then u lower, the lower limit, x is 0, so u lower is going to be that value 0 plus 3, which is 3. Okay, so check this out. This integral, if you substitute everything, including the limits, you're going to have the integral from 3 to 5 of 1 over u du. Okay, so here we go again. We encountered this problem in the previous example we resubbed, but this one we're just using u. Do not forget to change your limits anytime you're using u sub. If you do not change your limits, you must resub after integration. Okay? All right, so we changed the limits, so we're not going back anymore to the x's. What is the antiderivative of 1 over u? Antiderivative of 1 over u is the natural logarithm of the absolute value of u, evaluated from our new u's, 3 to 5. So this becomes the natural log of the upper limit minus the natural log of the lower limit. And then there you go. That goes our final answer. So this expression basically represents the volume of the solid with the given information. All right, so how was this problem scored on the AP exam? Let's take a look at that real quick. Question number 5B was worth 2 points. This was a 2-pointer. You get the first point for setting up your integral, 1 point here, and you get another point for accurately evaluating your integral to get this answer, for a total of 2 points. Alrighty, let's go ahead and take a look at part C. In part C, we're going to be looking at volume of solids of revolution. Okay, so that's what we've been assessed in this particular part. Part C reads, write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals 6. Okay, all right, so before we get started, let's go ahead and write down what the formulas are when you rotate a solid about a line to generate, when you rotate a region about a line to generate a solid. Okay, all right, so let's do this. So we're considering the formula for volume volumes. Well, there's two configurations. Okay, volumes can result from rotating the region about a horizontal line or a vertical line. In this particular case is a horizontal line. All right, so volumes, let's look at formula for volumes of solids resulting from revolution revolved around a horizontal line. All right, so that's the formula that we're looking at. All right, solids that result when a region is revolved about the horizontal line. All right, so the volume formula is as follows. It's going to be pi. So just remember this, very important. When you have a formula involving rotation to generate a solid, there's always going to be a pi component there in the formula, okay? All right, so integral pi of, you're going from x left to x right. Now, the axis of revolution could be above or below, okay? So that will impact our generation of the formula, but generally speaking, it's going to be pi times the integral from x left to x right of the outer radius r outer square minus r inner square. Okay, there you have it, and this is dx. All right, so how do you get r outer and r inner? It depends on where your axis is located, okay? If your axis is above your region, as in this case, y is equal to 6, this is the axis right here, 1, 2, 3, 4, 5, 6. When the axis is above, what's going to happen is that the axis will show up first in your setup, okay? So let me show you what the formula is, then we can discuss it later. So it's going to be the pi times the integral from x left to x right of your outer radius is going to be your axis minus whichever one is farther, which is the bottom function, square, minus your axis minus the one that's closer, which is going to be the one on the top, square, dx. Okay? So this is the formula when you have a scenario where a is greater than the top function, and of course everything is greater than the bottom function. So that's what we're going to be using for this example right here. Now what if you have a scenario where your axis is underneath the region? Well, in that case, we're just going to interchange the expressions in the parentheses and interchange our radii. Okay, so it's going to become pi times the integral from x left to x right of, so f top minus the axis. So you see how the second radius, we switched it around and moved it to the first, okay? This becomes our r outer because the top is farther from the axis than the bottom. So that's the outer radius, square minus f bottom minus the axis. This is the inner radius square dx. Okay, so this is when you have a situation where a is less than f bottom and f bottom is less than f top. Alrighty, so there you have it. So let me just show you what I'm talking about real quick. Let's use this graph to illustrate how we came up with these formulas, and then we're going to go ahead and set up the integral. Remember, for this particular problem, we're not evaluating, okay? We just want to set up the expression for the volume. So in this example, our axis of rotation A is 6. Okay, so a is 6. That's our a. We need to know the top and the bottom function. Is configured vertically. So this is going to be the one above. This is the f top right here. This is f top. I'm going to color code it so you can see exactly what's going on. And then this guy right here is f bottom. All right, so what is the outer and inner radii? That's the question. Let's find the outer radius first. The outer radius is the length from the outer function to the axis. Okay, so which function is on the outer in this example? So just think about outer as farther. Okay, so whichever one is farther out, that is what your outer radius is going to be. So let me show you what I'm talking about right here. Let's make it a little bit skinny. So this is farther out. So from here to here, let's go from here. So from here to here, that represents your outer radius, okay? Why is that? Because it's the farther function to the axis. So this length right here is r outer, all right? R outer is basically your axis minus f bottom. So you see, let's go back to the formula. You can see that right here. The axis minus f bottom represents your outer radius when the axis is above the region. Okay? All right, now what is your inner radius? Your inner radius is simply the closer function, the measure from your axis to the function that's closer to the axis of rotation, okay? And in this scenario right here, the top function is the axis of is the closer function. So from here to here, let's just put it right here. That length right there represents your inner radius, okay? So this is R inner, and R inner is clearly the axis minus F top. All right, so this derivation is just FYI. You can just use the formula to knock it out. And then another thing to note is that we have a nice collection of formulas that you need to know for the AP exam at our website, mathgotserved.com. So check it out, download the formula, and study everything so that you can do well on your exam, okay? All right, so let's go ahead and wrap this up. Let's figure out which is the top and the bottom. The top function, in part A, we determined that the top function was h of x, and then we determined in part A that the bottom function was g of x. Okay, so let's say the top is h and the bottom is g. So let's list everything that we know. Okay, so the A is the same thing. Well, let's put it, A is the same thing as x left. Okay, the left bound of A is 0, and then B is x right. The upper bound of integration is 2. F bottom is g of x, and then F top is h of x. These were determined in part A, and then our axis of rotation is above both of them, which is 6. So we're going to use this formula right here, bam, because A is greater than above F top and F bottom. So our volume is going to be given by the equation V equals, don't forget your pi, this is one thing that most students forget, equals the integral from x left to x right of the outer radius, which is the axis, minus F bottom, that squared, R outer square minus R inner square, which is the axis, minus F top, and that one squared. Integrating with respect to x, since the region is perpendicular to the x-axis. Okay, so that's another thing to keep in mind is where the region is perpendicular to tells you I didn't mean perpendicular, I mean rotation. So if you're rotating in the direction of the x-axis, because this rotation is like this, okay? If you're rotating in the direction of the y-axis, then it's going to be all x's. If you are rotating in the direction of your y-axis, then everything will have to be in terms of y. Very, very important. But in this case, we have a rotation about a horizontal line, which is in the direction of the x-axis, as specified in the formula. So that is why everything is in terms of x, 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 x. All right? So that goes the answer to question number 5C. All right, so how was this graded on the AP exam? This particular question is a 3-pointer. Okay. For this particular one, you get 1 point for the limits and the constant pi. That's 1 point right there. You get another point for the setup, setting it up correctly. And then you get another point for your integrand right here, your integrand components. This one will give you a total of 3 points on the AP exam. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming AP exam, do give us a thumbs up or a like. Your positive feedback is extremely valuable to us. Do not forget to subscribe to our channel for updates to other presentations such as this. If you have any questions or comments about what we did or any concepts in calculus in general, just place it in the comment section below and we'll be more than glad to respond. More support resources, including our epic formula sheet, can be found on mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.